Hi students, today in this session we are going to see about operations on signals. We are going to see about operations on signals. In this class we are going to see about operations on signals. Simply leave the signals first. If there are two numbers 9 and 15, so what are the operations that I can perform on the two numbers 9 and 15? So on 9 and 15 I can perform addition, I can perform subtraction, I can perform multiplication. Okay, so we can perform many operations on two numbers. Okay, 9 and 15. So 9 plus 15, so 24. Okay, 9 minus 15 or 15 minus 9 and 9 into 15. So we can perform many operations on two numbers. In the same way, we can perform some operations on signals also. So in this class, we will see what are the operations that we perform on signals. In this class, we will see what are the operations that we will perform on signals. Now, in signals, mainly the operations. So here the operations with respect to signals. Here the operations with respect to signals depend. The operations with respect to signals depend on two parameters. Here the operations with respect to signals depend on two parameters. In generally the operations will depend on or based on two parameters in general. So those two parameters are, first one is time and two parameters. Second one is amplitude. Okay, so here the operations on the signals are generally based on two parameters, that is time and amplitude. If you consider a signal A cos t, A cos t. Now that continuous time signal is based on many parameters. It's dependent on many parameters like amplitude, time, frequency, phase, many things. So a continuous time signal is based on many parameters, dependent on many parameters. If you change one parameter, then the signal will change according to the variation in the parameter. So of all the parameters, the time and frequency are interrelated. So for that I have taken time. And the next one is amplitude. I have taken amplitude. And the phase, if you change the phase of a signal, then the complete signal will change. That's why I will leave the phase. So with respect to operations, I will go only with the time and amplitude. Okay, time and amplitude. Here the operations on the signals in general are dependent on two parameters, that is time and amplitude. So first, with respect to time, what are the operations that we can perform? With respect to time, we can perform the operations like time scaling, time shifting, time reversal. Okay, so with respect to the time, I can perform the operations like time scaling, time shifting, time reversal. Okay, so these are the three operations that I can perform with respect to the parameter time. In the same way, with respect to amplitude, what are the operations that I can perform? With respect to amplitude also I can perform operations like amplitude scaling, amplitude shifting, addition, next subtraction, multiplication. Okay, so these are all the operations that I can perform with the respect to amplitude, and these are the operations that I can perform with respect to time. So now consider a signal a sine t. There is a signal like a sine t where this a is the amplitude of the signal and there is a time parameter of the signal. This t is the time parameter of the signal. Now if you want to perform operations with respect to amplitude, that is with respect to amplitude, I am going to perform the operations like amplitude scaling, amplitude shifting, addition, subtraction, multiplication. So I am going to perform this. I am going to perform this with respect to amplitude. At that time, there will be no change in time. There will be no change in time. That means the time parameter does not vary when we perform operations with respect to amplitude. With respect to amplitude. In the same way, if I want to perform operations with respect to time, then there will be no change in amplitude. If you want to perform operations with respect to time, if you want to perform operations with respect to time, then there will be no change with respect to amplitude of the signal. That is, there is no change in amplitude of the signal when we perform operations with respect to time. So you have to remember this point. Okay, so while we performing the operation with respect to amplitude, then there will be no variations in time parameter. If we want to perform the operation with respect to time, then there will be no change in the parameter of amplitude. The parameter of amplitude. Okay, so this is a basic thing reporting the operations on signals. So while you're going for the operations on the signals, in general, that operations on the signals are dependent on two parameters, that is time and amplitude. With respect to time, I can perform three operations, that is time scaling, time shifting, time reversal. In the same way, with respect to amplitude, I can perform five operations, that is amplitude scaling, amplitude shifting, addition, subtraction, and then multiplications. So in your syllabus, you have only four things. You have only four things. That is, with respect to time, you have only these two, time scaling and time shifting. With respect to amplitude, there is only amplitude scaling and amplitude shifting. That is, only these four operations are there in your syllabus. Okay. That addition, subtraction, and multiplication will perform on two numbers. In the same way, we can perform on two signals also. Simple logic. If you want to add two signals, I have to add the values at every instant of time. If I want to add two continuous signals, then I have to add the values at every instant of time. And if I want to perform subtraction on two continuous signals, then I have to subtract one signal from the other signal at every instant of time. In the same way, if I want to perform multiplication operation, I have to multiply the values, the two signals at every instant of time. Okay, simply. So these operations are well known to you: addition, subtraction, and multiplication. In that regard, they had given only these two in your syllabus with respect to amplitude. And here, coming to the time, they had given only these two. And the last one is time reversal. Actually, this time reversal is a special case of time scaling. I will explain at that time. This time reversal is a special case of time scaling. Simply, this time reversal is also called as folding operation, okay, or reflection of the signal with respect to time origin. You can call anything. It is obtained just simply by replacing t with small t. If I replace, there is a signal x of t. If I replace the small t with minus t, if I replace the small t with minus t, x of minus t, then I can get the time reversal signal. So Of all these 8 operations, addition, subtraction, multiplication and time reversals are a little bit easier for you to understand, because you are seeing these three right from your childhood, and this is also easy one, just it will obtained by replacing t with minus t. Okay, simple operation, hence it is called a folding with respect to time origin or reflection of the signal. Mirror image, it's like a mirror image. Time inverse reversal is like a mirror image. So as these time reversal, addition, subtraction and multiplication are very easy to understand, they doesn't give in the syllabus. So they had given time scaling, time shifting, amplitude scaling and amplitude shifting in your syllabus. So first I will explain addition, subtraction, multiplication. Okay, and then I will go for the syllabus. So there I will start with time shifting and then amplitude shifting, time scaling and then amplitude scaling. Okay, in this way I will proceed. So first I will start with addition operation on signals. So for this, to perform addition I need two signals, or to perform subtraction I need two signals, to perform multiplication also I need two signals. That is, I have to perform this addition, subtraction or multiplication, I need two signals, and I will consider those two signals as x1 of t and x2 of t. I will consider these two signals as x1 of t and x2. That means I will take two signals x1 of t and x2 of t as examples, and I will perform operations of addition, subtraction and multiplication on these two signals. Now I will explain everything, these operations, with respect to graph, that is with respect to diagrams, waveforms, with respect to waveforms. Why? Because the understanding of these concepts is very easy if we go with respect to the waveforms. So right from here I will explain these operations by the help of waveforms, that I will consider waveform for x1 of t, a signal, a waveform signal, and for x2 of t also I will consider a waveform. Okay, we'll draw the signal. Okay, based on the waveforms of respect to signals I will perform the operations, because understanding of that graphical representation is very easy for this topic. Hence I will use the waveforms while explaining the concept of operations on signals. Okay, I hope you are all clear up to now. So now I have to start the operation of addition operation. Okay, yeah, now we will see the addition operation. For that I have to take two signals. Now I am taking first x1 of t as one signal and x2 of t as another signal. Now here I have to perform the operation of addition. Okay, perform the operation of addition. Clear? Okay, addition. Now, so I already explained you that by taking waveforms, the concept of operations on signals will be very easy to understand. Okay, so for that, here for x1 of t I am considering a waveform. X1 of t I am considering a waveform like this. See, I am taking x1 of t as like that. 1, 2, -1, -2, 1, 2. I had taken a waveform like this. That is, this is t and this is x1 of t. This is one signal. Now, so this is first one, x1 of t, and in the same way, I had taken another signal. One, 2, 3, -1, -2, -3. 1, 2, 3. Okay, 1, 2, 3, -1. So this is x2 of t. Consider this as x2 of t. Okay. So here I consider two signals. One is x1 of t, another one is x2 of t. So on this, I have to perform the operation of addition. I have to perform the operation of addition. So here I will perform the operation of addition. So how will you perform? Simple. The addition operation is performed. Okay. just by adding the values of the two continuous signals, by adding the values of two continuous signals at every instant of time, at every instant of time. That is, at -3, I have to add. At -2.9, I have to add -2.8, -2, -2.5, -1.5, -1, 0.5. At every instant of time, I have to add the values of two signals. So I have to just add the value of x1 of t and x2 of t at this instant, at this instant, at this. So at the respective instants, I have to add the values, to perform the addition operation. The same way, for subtraction, I have to subtract the values. For multiplication, I have to multiply the values at every instant of time, at every instant of time. So see here, this is t, 1, 2, 3, 4, 5. The same way, 1, 2, 3, -1, -2, -3. So why I written like this? Simply, I said this addition operation is with respect to the amplitude parameter. With respect to the parameter amplitude. That means only the amplitude of the signal will change, and there will be no change with respect to the time. Here the time is from -3 to +3 and -2 to +2. So the larger one is this one. So I written that one. It hasn't increased because there is no change with respect to the time, but there is a change with respect to amplitude. So this maximum is 3. Here the maximum amplitude is 2. So total, I have to add the values. So 3 plus 2, 5. That is, there is change in amplitude. Hence I written 5 values here. I hope you are clear. As I said, while performing operations with respect to amplitude, only the amplitude will change, and there will be no change with respect to the time. And here I am performing the operation of addition. So addition is with respect to the amplitude. Okay, amplitude parameter. Addition operation is with respect to the amplitude parameter. Hence, only the amplitude of the signal will vary. There will be no variation with respect to time. Hence, I drawn like this. See, there is no variation. That means we have to start with -3. Simple. At -3, the value of x, we have to go for the value of x2, and -3 we have to go for the value of x1 of t. We have to both. See, at -3, the value of x1 of t is 0. At the -3, so I'm writing here, h -3, x1 of t equal to 0, and x2 of t equal to, x2 of t value is 3. So at -3, I need x1 of t plus x2 of t. 0 plus 3, that is 3. So that will be equal to 3. So at -3, the value of this one is 3. Clear? At -3, the value of this one is 3. Okay. See, from -3 to -2, the value of x1 of t is 0. So -3 to -2, the value of x2 of t is 3. So from -3 to -2, for -3 to -2, this x1 of t equal to 0, and x2 of t equal to 3. So equal to 3. So at that, up to that point. Okay. So if I add both x1 of t plus x2 of t, 0 plus 3 is 3. Okay. 0 plus 3 is 3. Clear? Now it is up to 3. Okay. So 0, -3 to -2. So for this value, there is 3. Yeah. See at -2. At -2, x1 of t is 2, and at -2, x2 of t is 3. 2 plus 3, that is 5. 2 plus 3 is 5. So at -2, the value is 5. the value is 5. Okay, the value is 5. Okay, from minus 2 to plus 2, from minus 2 to plus 2. See, here it is a constant. If there is variations in this time constant also, I have to consider. But for my example, from minus 2 to plus 2, there is no variation. In my example, from minus 2 to plus 2, there is no variations. So, as there is no variations from minus, because it is the amplitude is same. For that, I am considering from minus 2 to plus 2 at the same time. If there is any variations with respect to x1 of t or with respect to x2 of t, so I have to consider that time variation also. So whenever there is a change, if there is a change at this point, I have to consider only that. If there is a change at this point, I have to consider only up to that point. See here, from minus 2 to plus 2, there is no change. There is no change. Here also, from minus 2 to plus 2, there is no change. The amplitude is constant. In both the cases, from minus 2 to plus 2, there is no variations. So for that reason, I will take next from minus 2 to plus 2 directly. Remember, if there is any variations at minus 1, I have to consider at minus 2 to minus 1 only. If variation is at 0, if variation is at 0, I have to consider from minus 2 to 0 only. Okay, here up to plus 2, from minus 2 to plus 2, there is no variation. So I have drawn a straight line. Here also, from minus 2 to plus 2, there is no variation. If there is a variation with respect to either x1 of t or x2 of t, I have to consider up to that limit whenever there is a variation occurs. So here, from minus 2 to plus 2, I am considering. So minus 2 to plus 2, what is the value of x1 of t? That is 2. And x2 of t is 3. So I have to add this one, x1 of t plus x2 of t, which is equal to 2 plus 3, 5. So minus 2 to plus 2. Minus 2 to plus 2, the value is 5. After that, plus 2, there is a change. That is from 2 to it has given to 0. There is a change. So I have to consider this point. Now the maximum is 3 for our example. So 2 to 3. 2 to 3, here the value is 0. Here the value is 0 for x1 of t. For 2 to 3, the x2 of t value is 3. x2 of t value is 3. Okay. So next is from 2 to 3, x1 of t equal to 0. So 2 to 3, x1 of t is 0. There is no signal. There is a change. That is from amplitude 2 to 0, it has come down. And x2 of t equal x2 of t equal to x2 of t equal to, so 2 to 3, it is 3. Now x1 of t plus x2 of t equal to 0 plus 3. How much? 3. So from 2 to 3, the value of x1 of t plus x2 of t, that is, this is our x1 of t plus x2 of t. So the value is 3. So here this is 3. See, that is from 2 to 3. 2 to 3. 2 to 3. So this is 2 to 3. You can write like this. Okay, 2 to 3. So there we can draw like this. Clear? Yeah. So 2 to 3, it's 2 to 3, its value is 3. After 3, here is 0, here is 0. 0 plus 0 is 0. So after 3, it is all zeros. After 3 and less than minus 3 is 0. So this is how we will perform the addition operation. This is how we will perform the addition operation. Okay. So now we can perform x1 of t minus x2 of t or x2 of t minus x1 of t. So I will do one and you will do other for your practice. So here I will go for x1 of t minus x2 of t. Now next one is I have to go for x1 of t minus x2 of t. So I am performing that one. Okay. 1, 2, 3, minus 1, minus 2, minus 3. 1, 2, 3. If you go downside, minus 1, minus 2, minus 3, so on. Okay, like this. So I taken this one. Now what operation I have to perform? X1 of t minus x2 of t. So I will go a little bit faster because here I explained everything in a slow manner. Because lack of time, I will go a little bit faster. See, right, first from here to here. So this value minus 3 to minus 2. This value is 0, and this value is 3. So 0 minus 3, 0 minus 3, 0 minus 3, that is minus 3. So that value is minus 3. From minus 3 to minus 2, minus 3 to minus 2. Okay. So at this point the value is 3. At this point the value is 0. So x1 of t minus x2 of t, that is 0 minus 3. So you will get minus 3. Simple. Minus 3. Next, from minus 2 to plus 2. Minus 2 to plus 2. This value is 2. And this value is 3. So x1 of t is 2. x2 of t is 3. From minus 2 to plus 2. So from minus 2 to plus 2, the value of x1 of t is 2 and the value of x2 of t is 3. 2 minus 3, because I am performing the operation of x1 of t minus x2 of t. Simply 2 minus 3, that is minus 1. So we get minus 1. From minus 2, this is the minus 1, point is, that is from minus 2 to plus 2, the value is minus 1. After that, 2 to 3. 2 to 3. Here is 0. Here is 3. Here we have 0 and here we have 3. So x1 of t minus x2 of t. 0 minus 3. That is minus 3 again. So from 2 to 3, the value is minus 3. Minus 3 is like here. So here we have to go this. Minus 3. Am I right? So from 2 to 3, it is minus 3. Minus 3. Hope you are clear. So this is subtraction operation. This is subtraction. Okay. That is x1 of t minus x2 of t. So I am giving you to do the operation x2 of t minus x1 of t. So perform this at your home. So do this at your home for your practice. Simply it will come as reverse to this. So perform this at your home. Now I will finish with last one, that is multiplication. Simply multiplication. Simple one, multiplication. Okay. Now the same signals 1 and 2. I have to perform the operation of multiplication, that is x1 of t into x2 of t. So for that 1, 2, 3, minus 1, minus 2, minus 3. So this is t. And this one is x1 of t into x2 of t. x1 of t into x2 of t. Simply, so I am performing the operation of multiplication. Consider the signal. Say the limits minus 3 to minus 2. x1 of t is 0. Minus 3 to minus 2. x2 of t is 3. 0 into 3. First I have gone for 0 plus 3. Next 0 minus 3. Now I am going for 0 into 3. 0 into 3. 0 into 3 is 0. So that is from minus 3 to minus 2, the value is 0. Next see. From minus 2 to plus 2. From minus 2 to plus 2, x1 of t is 2. From minus 2 to plus 2, x2 of t is 3. So multiply those values. 2 into 3. Nothing but 6. That is from minus 2 to plus 2, the value is 6. So 1, 2, 3, 4, 5, 6. Consider this. So right from minus 2 to plus 2, we have 6. Right from minus 2 to plus 2, we have 6. Okay, 6. Next 2 to 3. x1 of t is 0. 2 to 3. x2 of t is 3. 0 into 3. Again it is 0. So 2 to 3 it is 0. So minus 3 to minus 2, 0. 2 to 3, 0. Inside. So from minus 2 to plus 2, x1 of t is 2 and x2 of t is 3. 2 into 3, 6. So minus 2 to plus 2, the value is 6. So this is the operation of multiplication on these two signals. Here see, all these operations are with respect to the parameter amplitude. With respect to the parameter amplitude. Hence, the variations are with respect to amplitude. Here, in addition, the variation is with respect to amplitude. Time is from minus 3 to plus 3. Here also, with respect to amplitude, there is a change. Time is minus 3 to plus 3. Here also, there is a change with respect to amplitude. The time is from minus 3 to plus 3. That is, in all the cases, the change is with respect to amplitude only, because the operations addition, subtraction and multiplication will be performed with respect to the parameter amplitude. So the changes will occur only with respect to amplitude, and there is no changes in time. So the time changes will occur whenever we will perform operations on time. That is like time scaling, time shifting, time reversal. Okay. So in this amplitude, we'll have to with two operations. That is amplitude shifting and amplitude scaling. Amplitude shifting and amplitude scaling. So in next, I will explain you about time shifting, time scaling, time reversal, amplitude shifting and amplitude scaling. So the continuation of this class is time shifting. Now we will move on to the actual syllabus content. So that is time shifting operation. That is time shifting operation. See, the name itself tells the shifting is with respect to time. That is the shifting. What is shifting? Shifting is nothing but moving. So the moving of the signal, the shifting of the signal is with respect to time. So time variable. Okay. And is there any change in amplitude? No, it doesn't have any change in amplitude. Now, so if I want to perform a time shifting operation on a signal, for that I am considering a signal as x of t. Let us consider a signal as x of t. I am considering a signal as x of t. Now I have to perform the time shifting operation on that signal. What I have to do? I have to perform time shifting operation. Okay. So on this signal x of t, I performed time shifting operation. And it is producing some output. In generally, we will take output as y of t. That output is equal to, so if I perform the time shifting operation on x of t and it is producing a signal like this, x of t minus some constant, you may take anything. So x of t minus m. So here in place of m you can take anything. You can take k, you can take s, whatever it may be. I had taken m. It's a function of time shifting on a signal x of t. That is, if you perform the time shifting operation on a signal x of t, it will produce the equation as x of t minus m. Okay, x of t minus, that is x of t minus m is the time shifting operation of x of t. First thing. Now, this time shifting operation results in delay of the signal or advance of the signal, that means if you perform the time shifting operation on the signal, it will result in either delaying the signal or advancing the signal. So the output of this will result in two ways, either it will delay or advance the signal. Now, how will you know whether the signal is delayed or the signal is advanced? How the operations will perform? That is based on this one, this letter M. Simple. If M is positive, it is a positive value. M is a positive value. Then what happens? If M is positive, Let us take, for example, I am taking m value as plus 3, m value as 3. The signal is x of t, and I have taken the m value as 3. Then the time shifting operation, the result of the time shifting operation is x of t minus 3. T minus 3. That means here the m is 3. That 3 is a positive value. So whenever this m is positive, then the shifting is to the right side. Then the shifting or the shift is to the right side. The shift is to the right side. Okay, right side of the signal. So if you take this as origin, 1, 2, 3, minus 1, minus 2, minus 3. For this will be the right side and this will be the left side. So for this is right side and this is left side, right side for this. Now if m is positive, then the shift is to be the right side. That is, the shifting is towards right. So it will move this side. If the signal starts at 0, x of t starts at 0. Now x of t minus 3, that is, it should be shifted 3 units right side. That is 1, 2, 3. So the signal has to start from 3 for x of t minus 3. If the signal x of t starts at 0, the same signal x of t minus 3. For x of t minus 3, the signal has to start from 3. The remaining all are same. The shape of the signal is same. Everything is same. Okay. So only the starting point of the signal is from. So from 0 to 4 it is moving. The signal is from 0 to 4. X of t minus 3 will give that the signal will move from 3. Actually, it is from 0 to 4. So x of t minus 3 from 3 to 7. That is, add that 3 for the starting point and add that 3 to the ending point. That is 0 plus 3, and then here 4 plus 3. 4 plus 3 is 7. So I explained just outline. Now see, if m is positive, then the shift is to the right side. First one, the shift is to the right side. Clear? Now, as it is right side, that shift results in delay of the signal. That is, if the shift is to the right side, then the shift, this type of shift results in delay of the signal. Results in delay of the signal. If m is positive, then the shift is to the right side, and this type of shift will result in delay of the signal. That is, the signal is delayed by this delayed by m. If it is a time, m seconds, or if any other value, m units. That is, the shift is to the right side, then the signal will be delayed by m seconds. For your better understanding, I will give a simple examples. Remember this example, then this concept is very, very easy. That example is, let us take from Guntur railway station. A train has to start by 10 o'clock. This train has to start by 10 o'clock and it has to reach Vijayawada by 11. So in Guntur, the train has to start by 10. So consider this as a 10. If it starts by 10:03, that means it is started late by 3 minutes. That is, it is delayed. So keep this example in mind. So if actually it has to start at this point, that is 10, but it started at 10:03. So here actually the train has to start at this point in the Guntur station, but it started at this point. So 10:03, that is, it is delayed by 3 minutes. Okay, it started late by 3 minutes. Late is delayed. So it is delayed by 3 minutes. Okay. Now, if m is negative, then the shift is to the left side. Then the shift is to the left side. Left side will have the shift. Okay. And this type of shift results in this type of shift, left side shift or negative shift, will results in advance of the signal. Results in advance of the signal. So that is, signal is advanced. So it has started earlier. It is advanced. So same example. Now the train has started at 10 at the Guntur railway station, but it started at 4 minutes before. 4 minutes before. That is, it started by 9:56. 9:56. Okay. So -1, -2, -3, and -4. So 4 minutes. It started somewhere here. So that is, it is started earlier. Actual time is 10 o'clock, but it started by 9:56. 9:56. In the same way, the signal has to start at 0, but according to the m value is negative. So as the m value is negative, so what happens to this x of t minus m? What happens to x of t minus of m is negative, minus of minus m, that is x of t plus m. So if you have equation like this, x of t plus m shifting, the shifting operation is like x of t plus m, then the signal will shift to the left side of this m seconds, okay. Now here, same, consider m equal to 3, that means t plus 3. So what you have to write? X of, I am writing here, x of t plus 3. So t plus 3 means it has to move to the left side. This is 0, 1, 2, 3. So it moves left side, this side 3 units. That is, the signal has to start at this point. Let us take, the signal is like this. So it will start at this point. Total is 3, 1, 2, 3, 1, 2, 3. So this is the actual signal. If it has to shift left side by 3 units, then the signal will look like this. It is shifted left by 3 units. That means the signal has started earlier. That is, it is the advance of the signal. So before the actual time it started, that is, it is the earlierly it is started. That is advance of the signal. So this we call it as advance of the signal. So from this explanation, you have to remember only 2 things. So the shifting operation will be like this: x of t minus m. If m is positive, then the shift is to the right side, and that shift will result in delay of the signal. If m is negative, then the shift is to the left side, that is to the negative side, negative shift. This type of shift will result in advance of the signal, and thus equation represent as x of t plus m. Okay. See, I will give you the graphical diagrams, graphical representations for your better understanding. Okay, graphical representations. Let us take, I will consider a signal. First, I will consider a signal. This is t, this is x of t. Okay, and the signal is started from this point. Okay, started from this point, goes like this and goes like this and stops here. So this is my signal. This is my actual signal. Okay, this is my actual signal. Now I have to go for time shifting. Now we have two shifts, positive shift and negative shift. Positive shift and negative shift. So if it is positive, that is the value of m is positive, it is a positive shift. So the positive shift is represented with x of t minus m. This shift is to the right side, that is t. Okay. Now how can you represent that one? So here somewhere the value of m is there. If m is there, so it will start after m seconds. The signal will start after m seconds. M seconds. The height will be same. The amplitude is same. Then up to which time it will, up to where it will stop? Simple. It started at 0 and ended at, let us take as 3. Ended at 3. So it started as m. That means 0 plus m. So it started at m. Then where it has to end? So 3 plus, that's where we added, that is m, or simply m plus 3. So it has to stop at m plus 3. M plus 3. Okay, or 3 plus m. You can write anyway. M plus 3 or 3 plus m, both are same. So actually it has to start at 0, but it started at m. It has to end at 3. It has to end, it will end at m plus 3. It will end at m plus 3. Clear? So this is nothing but right shift. See, it has delayed the signal by m seconds. Delayed the signal by m seconds. Now see, the same signal, if, say for the same signal, if the m value is negative, that is x of t minus of minus m, that is x of t plus m. Now the signal is like this. Signal is x of t plus m. X of t plus m. How the signal will go now? That is, it has to be delayed. It has to be delayed by it has to be delayed advance, because it is x of t plus m. X of t plus m. Then the shift is to the left side, that it will result in advance, not delay. It will result in advance. Now the signal has to be advanced by m seconds. Advanced by m seconds. That means it has to start early. Actually it has started here. Now it has to start early by m seconds. So I have to consider, this is m, so somewhere like this, minus m, and it has to start at this point, and the amplitude will be same. And where it has to end? It has to end. Where it has to end? It has to end at a value minus m plus 3. Minus m plus 3. So I have to add that value because it is from 0 to 3. So for first one, that is in delay of the signal, it is represented to x of t minus m, that is m to m plus 3. And the next one, advance of the signal, that is it is started m seconds earlier, that is from minus m to minus m plus 3. Minus m to minus m plus 3. So this is how the time shifting operations will look. There are two types of shiftings: right shift, left shift, positive shift or negative shift. So this shifting result in either delay of the signal or advance of the signal. If it is if the shift is towards the right side, then there is the delay of the signal. If the shift is towards the left side, then there is the advance of the signal. So for that I explained you by taking an example as this one, and for that first I gone for the positive shift, that is to the right side, that is this is the delayed version of the signal, x of t minus m, and next I gone for the advanced version of the signal, that is x of t plus m. Here I consider the m value as negative and here I consider the m value as positive. Okay, so these are the examples. Now you can go for a better examples. Here I had taken m. Now leave that m, take that m value as something. Okay, now see, I will give you one more example. So first I will take See, this is the one, this is the signal. For the same signal, if m value is 2, if m value is 2, then how the signal, then you'll get a better idea, okay, better picture of what this time shifting is. Here for the same signal I had taken m equal to 2. Now what I have to write? I have to write x of t minus 2 and x of t plus 2. You have to write x of t minus 2 and x of t plus 2. First write x of t minus 2, that is x of t minus 2, that is the delay version of the signal. So t minus 2, whenever there is a t minus 2, x of t minus 2, simple operation, t minus 2 equal to 0, t equal to 2, that is plus 2, this is a positive, that is the right side. Whenever it is the right side, that is the delayed version. Okay, so how will you write? Take this as t and move it to the right side by 2 units. So this is 3. 1, 2, 3. Now see here. 1, 2, 3, 4, 5. 1. This 0. 1, 2, 3, 4, and 5. See 5 values. Now this is the x of t signal. Now I am performing x of t minus 2. X of t minus 2. That means the shift is towards the right side. There is a delay of the signal. That is delayed by 2 seconds. 2 seconds. So actually the signal has to start at 0. But now it will not start at 0. It will start at this one, 2. How the signal shape is? This one. What is the amplitude? Take 1, 2. Take the amplitude as 2. 1, 2. Okay. Clear? It will move on. Now what happens? Go on. Where it will stop? Actually the signal is, amplitude is 2 for 3 seconds. 1, 2, 3. 0 to 3 seconds. Actually it started second. That is, from there it has to move for 3 seconds. That is 3, 4, 5. To move for 3 seconds. That is 3 units. Okay. See, that is the signal for x of t minus 2. X of t minus 2. In the same way, we can go for x of t plus 2 also. In the same way, we can go for, so here I will go for x of t plus 2. It is t. See, for the signal x of t plus 2. So t plus 2 equal to 0, the t equal to minus 2. Minus 2 means left side, there is a negative shift. This shift results in the advance of the signal. So the signal will be advanced by this factor, that is 2. There I had taken m, here I had taken 2. So it will be started 2 seconds earlier. The signal will start, this signal will start 2 seconds earlier. 2 seconds earlier. So from where it will start? Okay, this is 0, this is 1, this is 2, and this is 3. In the same way, this is minus 1, minus 2, minus 3. Where will it start? It will start 2 seconds earlier. 2 seconds. Actually, it has to start at 0. But 2 seconds means minus 1, minus 2. It will start at this one. And the amplitude, there is no change. If it is 2, amplitude is same, 2. The shape, amplitude, everything is same. And here it started. Where it has to end? It has to end after 3 seconds. So from here, 1, 2, 3. So it will end at this one. Or simply, in this I had written where it has to end, minus m plus 3. So here minus m is minus 2. Minus 2 plus 3. Minus 2 plus 3 is plus 1. So for that reason, it has ended at plus 1. The simple way to represent the time shifting operation. How will you represent the time shifting operation? So the time shifting operation will result in either a delay of the signal or advance of the signal based on the right shift and left shift. If the shift is to the right side, then there will be delay of the signal. If the shift is to the left side, then there will be advance of the signal. So I had given the graphical examples also for your better understanding. I hope you are all clear with the time shifting operation of a continuous time signal x of t. Continuous time signal x of t. Now I will give you the work. Now you have to go for the time shifting operation with respect to discrete time variable. Discrete time variable. That is, discrete time variable is n. Discrete time variable is n. Okay. Now you have to explain with. You have to do the work with respect to discrete time variable. That is, there the discrete time signal is, consider the discrete time signal as x of n. X of n. So for that discrete time signal, we will do the operations of time shifting. So that is, take there a letter as other than a k. So x of n minus k and x of n plus k. X of n minus k and x of n plus k. One is the right shift and another one is the left shift. That is, here there is the delay. For right shift there is the delay in the signal. For left shift there is the advance in the signal. Here is a continuous signal, that is a discrete signal. So you have to take the signal like this. Discrete signal. 1, 2, 3, 4, 5. Consider this as a signal. N 0, 1, 2, 3, 4. This is a discrete signal. X of n. For this you can go for x of n minus k and n plus k. The concept is same. The concept is same for discrete time also. Okay. Only the t is replaced with n and m will be replaced with k. So I hope you will do the time shifting operation for discrete signal, that is x of n. So do that for your practice. Do that for your practice. So this is completely regarding about time shifting operation. So in the next class we will go for amplitude shifting. Okay. Thank you one and all.